Hi all, this is Monisha, a research scholar, Department of Computer Science and Engineering from Siva Subramanian Nadar College of Engineering, Chennai. Today my talk is about MLIBT, a multi-level improvised binarization technique for Tamizhi inscriptions. I would like to thank International Research Awards and Computer Vision to select this project for research awards. Introduction. Many information about our Asian culture is still unknown, but some are already documented in various epigraphs, which are written in various mediums like rock pillars, temple walls, copper plates, poetry, palm leaf stones, and many more. These informations are the basic source to know about the history of past, and it's also used to analyze the human civilization to record their own information. Today, the Tamil modern script has been evolved over ages from the ancient Tamil characters. From this, Tamil inscription, which is one of the oldest ever discovered, which is dated from 5th century BCE to 3rd century CE. Today's generation needs ways to interpret the script in order to know the historical figures and events, since Tamil script has been evolved into modern script over time. Also, only very few epigraphists are available nowadays to manually decode this inscription to a modern language. In order to preserve this information and our cultural heritage, we find an alternative way. So, we are going to digitalize the epigraphist's work and converting the text in the images, and finally recognize the content which is present in the inscription images. We also know the binarization of Tamil inscription images are high complex due to various environmental factors. Also, it has similar foreground and background color with uneven shape and structure of the stone. They are all handwritten. Because of these issues, the existing binarization approach produced poor results on Tamil inscriptions. Also, the existing binarization algorithms work only on flat stone background, and it requires sufficient light illumination for effective binarization. In order to address all these challenges, we have to propose a multi-level improvised binarization solution in order to binarize the Tamil inscription, which have a irregular shape and structure and similar foreground and background color, which has been vanished and ruined due to various environmental factors. This slide shows you the previous work of this area. In this, many authors have worked on inscription images, but all these inscription images are later period with a flat background. But in this survey, we have seen that some of the authors like Suganti have worked on an uneven stone and various illumination. Also, two more workers in uneven stone and various illumination like Bharat and Durga Devi. But all these inscriptions are all these works carried out in a later period inscriptions like Chola and Kannada inscription, which have a flat background. When it comes to a curved background, the author view has been worked on an oracle bone dataset which have a curved background, but since it has curved background, it has a smooth texture and good lightning for for that oracle bone inscription to process the binarization algorithms. From this literature review, we have analyzed the various objectives for our presentation. Today, we have four objectives. First one is to create the standard Tamil data set, which has been captured on site by various sites of Tamil Nadu, and some of the informations and the inscription which is not present on site are collected from various archaeological survey of India. Also, the collected data set has been annotated and validated by the subject expert and domain experts. The second objective of this work is to enlarge the custom data set by data augmentation, because we all know deep learning is a technique which uses more data in order to analysis and process the features of the content automatically. Since we have only few inscription, we are opting for the data augmentation. But even though we are augmented, it fails. The third objective is to develop a multi-level improvised binarization technique for Tamizhi inscription in order to segment the foreground text from the background. We are applying improved median filter, iterative thresholding, and the modified adaptive thresholding in this third objective. Finally, the final objective is the post-processing optimization of the binarized result, which is uptime from the multi-level improvised technique using swell and shrink filters. Let us discuss about the first objective, which is a data set. The historical evidences of the Tamizhi inscriptions, which dated belongs to of BC to a 3rd CE, as dated by the archaeological departments, as these inscriptions are available in 31 sites of Tamil Nadu, which are collected by on-site for this work. All these inscription images are captured using 25 megapixel camera with a resolution of the 300 dpi. Also, this inscriptions has been collected in different orientation and illuminations for better efficiency. Finally, we have 396 images of Tamil inscriptions. The captured inscriptions are annotated by 6 annotated in various fields of archaeology, epigraphy, history, and linguistics by using a universal data tool. These annotated images by various annotators are finally verified by Mr. Kurandai Velan, Deputy Superintendent Epigraphist, Tamil Nadu Archaeological Department, retired. He also served as 50 years of experience in this field. After the verification of the subject expert, the annotated data has The annotated data has analysis for kappa score with 0.84 and it considered as a standard dataset for this work. Now, the second objective is the challenging in deep learning. The deep learning methods for binarization was not attempted so far in binarization of inscription images. Since the inscription images are affected by various environmental factors, we have to capture the inscriptions on site in every situation while we are training a model. It also reported that only few works has done for inscription, but it's for recognition and classification task, not for binarization. One of the important characteristics of the deep learning, it has the ability to perform the feature engineering of its own. So we have to train with huge amount of data in order to perform it automatically. Since a Tamil inscription data sets are very less, we have collected only 150 inscriptions all over the world, which are highly insufficient for a deep learning training. We are going for a data enlargement technique called GAN, that is a generative adversarial network. By using a GAN framework, we have to increase the size of a data set. But since the data augmentation doesn't work well, the accuracy and the losses are similar to the original dataset. So we are planned to add some more inscriptions which are similar to a Tamil inscriptions for a better accuracy. We have added Chora and Vatteluthu inscription in order to enlarge the Tamil dataset for deep learning processing. From this, it's inferred that the model underfits and doesn't learn from the data. As the combined dataset result doesn't improve in binarization for Tamizhi because it has a less data and it has different textures which have similar foreground and background color when compared to other two scripts. Based on this aforementioned issues in binarization, we plan to resort our traditional binarization method in order to segment the foreground and background color of Tamil inscription images. Finally, we came for MLIBT, which is our third objective and the purpose of this work. It shows a system methodology. In this image, the original RGB has been fetched to our system MLIBT. In that, the RGB images are contrast touched and it converted to a gray from RGB. The converted grayscale images are undergone the process like improved median filter, histogram, additive thresholding. From the additive thresholding, we find the optimal thresholding and gone for a modified adaptive thresholding. Finally, we have post-processing and get a final output for our work as binarized images. This slide shows you the cave inscription and the memorial stone of Tamizhi, which is in RGB. In the slide, we are planning to enhance a contrast to enhance the visual quality of the inscription by stretching the intensity value of the images. The intensity pixel of the images are adjusted to low or high in order to enhance the visual clarity of the engraved text which is present in the inscription images. By using this formula, we are enhancing our inscription images. This figure shows you how the original inscription images are enhanced to contrast enhanced image. Then the next slide shows you the enhanced images are converting into a grayscale images. Usually a grayscale images are from the RGB values of each pixels by assigning that reflect the brightness of that pixel. During this conversion, we all know the darkest pixel are converted as black and the lightest pixel as white. The intermediate pixels are the gray shades which representing the brightness of the individual RGB components. But in our cases, we are taking a red component more when compared to other two components instead of taking equal contributions of each component. Since inscription images are present are engraved in rocks due to the presence of iron oxide which is a dye mineral, it gives a rock a very deep red color. So in order to segment this, we are enhancing the red color more when compared to other green and blue. The results of grayscale images of enhanced has been shown in figure 4. Then improved median filter. This inscription images have many random noise because it's captured in uneven variation of brightness, color and texture. We all know these random noises includes impulsive, Gaussian and salt and pepper. Generally, median filter removes impulse and salt and pepper noises and veiny remove the Gaussian noises. But the veiny filter also removes the fine details of the edges and points in the images. We have to preserve that edges and points while removing the random noises. In our improved median filter, we proposed we have to remove the random noises without the losing fine details and preserving the edges and smoothing the inscription images. In some of the Tamil inscription, for example, it's shown in figure 2b, the memorial stone. The entire stone inscription is identified as foreground, just only the rather than text, the stone itself is identified as foreground. But in our case, it's supposed to extract only the stone from the text from the stone as foreground, not the stone. So next, in the next slide, we are estimating the threshold. We obtained a noiseless inscription images from the improved median filter, which have a non-uniform illumination and uneven intensity. Optimal threshold is used to avoid the misclassification of foreground and background classification. By choosing the optimal threshold, we can get the binarization process more accurate for segmentation. To overcome this, we are using iterative thresholding to segment the pixels with bimodal distributions. We are applying histogram projections depends on the window size to smoothen the images. The local histogram is calculated by increasing and decreasing the window sizes. Since the threshold is calculated for each pixel from 0 to 225, the inscription images are identifying optimal threshold in order to perform better. We are identifying the probability of foreground and background by Gaussian distributions, and the a priori probabilities are measured to differentiate the background and text. Finally, the overall probability error has to minimized with respect to change in threshold and identify the optimal threshold. The process is repeated for all the pixels in the images in order to calculate the optimal threshold value for each pixel sum. Then the modified adaptive thresholding have the optimal threshold for each pixels in the inscription images. The correlation coefficient of these threshold values are analyzed to decide whether each pixel belongs to an image of white or a black. Even though the modified filter removes the noises which is present in the grayscale, some random noises are still present in binarized images, which are also classified by using the correlation coefficient considering the value of 0.3 to 0.7. We are using a Pearson correlation coefficient in order to measure the relationship of pixels with its neighborhood. Due to this, some edge pixels can be corrected in the binarized images. Finally, these kind of noises will be removed in post-processing. Post-processing, which is a fourth objective. The post-processing improves the quality of the binarized images by restoring the mixing pixels and filling the small textual parts of swell and string filters. Generally, swell filters used to improve the quality of the character by filling the possible gaps in the foreground text. These filters work with the lexicon to improve more accuracy on characters. It also inspects each background pixel by scanning the entire images using n-cross and sliding window and find any background in the center, then it changes to foreground. Also, it restores a mixing pixel by increasing quality of the foreground text. Then comes to a shrink filter, which is used to remove the noise from the background images. It works similar to swell, but N-cross and sliding window of background pixels has foreground in the center that has been changed to a background pixel. Therefore, the string filter is used to fill the gap and breaks of the text by removing the isolated pixels to preserve the stroke connectivity. This slide shows you the results of cave inscription and memorial stones by using various existing algorithms, and finally our proposed MLIBT method. When comparing to all the existing binarized inscription, it shows better results on our MLIBT method. Finally, the conclusion of this work is that we have attempted binarization using deep learning, and the existing binarization works which performs on which performs poor on inscription since it's on application specific. The accuracy for binarization of inscription images for Birdsson is 42%, Badley is 50%, Savla is 58%, Niblock is 70 and Kapoor is 74. Also, we all know the well-known generalized method Odshu also fails for this Tamil inscription because of uneven illumination texture and background. It produced accuracy of only 52%. But our MLIBT method performs better with the accuracy of 92.19. It preserves the results well by extracting the text which is already shown in the result part. Finally, the application of this work generally generation today are unable to read the Tamil script since it's one of the older script or it transformed over times into modern Tamil. So this project will be helpful for various field persons in the society such as archaeologists, epigraphists and field researchers in order to identify the notes on architecture, trades, business secrets, medicinal scripts and many more. The text in Tamil inscription has been degraded in several ways making it challenging to read. But MLIBT assists in extracting this text and displaying it to user in an understandable format. Also, the general public can understand the content in their local languages if this text is further transliterated into contemporary languages. Finally, I would like to thank International Research Awards and Computer Vision for choosing this as best research project. Thank you, Mananda.